completing the square can also be used to solve. Let's take a look at that method. So we're going to do the same series of steps. We want to get the x squared and the x term alone, which means this term needs to move over. So we'll have x squared minus 10x equals, if we subtract 21 from both sides, we'll get negative 21. Now you may be tempted to factor out an x from both of these terms, but remember, we need that in there because now we're going to complete the square. So we have x squared minus 10x, and then I'm going to put a big space there because we're not sure what that third term is going to be just yet. I'm going to take my x term, my negative 10, the coefficient for the x. I'm going to divide it by 2. When I divide it by 2, let me write it over here, kind of out of the way. Actually, I'll write it down here in the bottom. I'll take my negative 10, divide it by 2. When I get that, when I do that, I get negative 5. And then I'm going to square that negative 5, and that'll give me positive 25. So that's the number I have to fill in here. And that's also the number that gets filled in on the other side. So now I'm ready to write my trinomial as a binomial squared. I take the square root of the first term, square root of the last term, sign in the middle number, and I'm done on that side. On the right side, I combine like terms. Negative 21 and a positive 25 is 4. So now, how do we solve this? Well, if I have something squared, then I would take the square root to solve it. So I'm going to take the square root of this side and this side, and we are going to be looking at both the positive and negative root. So on the left side, I'll just be left with x minus 5. On the right side, I'll be left with positive or negative 2. And then when I continue solving, I get x equals, by moving this over to the other side, add 5 to both sides, I would get x equals 5 plus or minus 2. So that's going to give me 2 solutions. X equals 5 plus 2 will give me 7, and x equals 5 minus 2 will give me 3. And you should take both of those solutions and plug them in to your original equation. Make sure they both work. Okay? All right, let's look at another one. One more. I'm going to do the same thing. I'm going to follow the process of completing the square, which means this needs to move to the other side. So I have 2x squared minus 20x equals negative 47, because I would subtract 47 from both sides. Then I'm not going to factor out the x, right, because I need the x squared and the x to complete the square. But I can't have a number other than 1 in front of my x squared term. So I'm going to factor out the 2, just so that I have x squared by itself. So I have 2x squared minus 10x. Oh, this is looking similar to the last one we did. And then I'm going to leave a space and write what I have on the other side. So now to get my middle term, my last term here in the trinomial, I'll have to take my middle term, which you can see it's the same number that we had down here. My middle term, divide it by 2, that gives me negative 5. Square that, and I get positive 25. Now, when I add to the other side, I'm not just going to add 25, because this 25 is being multiplied way out here by a 2. So it's not really a 25, it's a 50, because 25 times 2 is 50. So I'm going to add 50 to the other side. Okay, so now I'm ready to write my trinomial as a binomial squared. Square root, sine of the middle term, and that's going to be equal to negative 47 plus 50 is 3. So there's going to be an extra step involved here when I'm finding the solutions. I have to first isolate. Just like we isolated radicals when we solved those equations, I have to first isolate the binomial that's being squared. So I'm going to divide both sides by 2 right from the beginning. That's going to leave me with x minus 5 squared equals 3/2. Now I'm going to go to the step where I square root both sides. When I square root both sides, on the left I have x minus 5. On the right, I just have the square root of 3/2. Right? So, plus or minus. So when I add 5 to both sides, I can't add them on the right because they're not like terms. So I can leave it, I can leave it as 5 plus or minus the square root of 3/2. That would be my final answer, and that would give us 2 solutions. It's just that they're going to be irrational because 3/2 is the same as 1.5. So I'm taking the square root of 1.5, and I'm going to add it to 5, and that'll give me 1 solution. I'm going to subtract it from 5, and that would give me the second solution. If it asks you for an approximation, you would actually do that. You would use your calculator, put in 1.5, take the square root, round it to the, I guess, nearest hundredth or thousandth place, and then do the addition and subtraction and get 2 solutions. But most of the time, you're going to be asked for the exact solution or the exact value. When you see that word exact, that means you leave it in square root form. You don't find a decimal approximation.